Hi, welcome to my channel. This is Nice Monkey Science. Previously, you might have been forgiven for thinking that all substances or matter are made up of little tiny particles that look like circles, like over here, with the different states of matter, gas, liquid and solid. Actually, these particles are a little more complicated, and everything that we know of are made up of particles known as atoms. These are the smallest particle that something exists in. In addition to that, these atoms also contain subatomic particles, and it's this atomic structure that this video is explaining. Atoms were originally thought of as plum puddings. A plum pudding is a bit like a Christmas pudding. It was thought that the bulk of the atom was positively charged, and throughout the atom there were negatively charges scattered, a bit like the fruit scattered throughout the Christmas pudding, or in this case plums scattered throughout the plum pudding. This plum pudding model was made by Thomson. However, when an experiment was carried out where an alpha particle was shot through some gold foil, the alpha particle, which is positively charged, was expected to travel through in straight lines, as shown up here. However, the observed result was that the alpha particle was scattered in all directions. This led to new models being created by Rutherford and by Bohr, and eventually the accepted Rutherford-Bohr model that we use today. This model came about because of the scattering of the alpha particles, and they seem to suggest that there was a central positive area in the atoms. So it was determined, instead of the positive charge being distributed throughout the whole of the atom, that it was concentrated in a central area that we've come to call the nucleus. The term subatomic particles just means within an atom, or the particles found within the atom. They each have their own mass. The particles vary with mass, charge, the location within the atoms that they're found. The basic atomic structure consists of a central nucleus. So this area in the middle, just like in the middle of a cell, is known as a nucleus. It contains two different particles. As you can see here, they're represented by a green particle and a red particle with a plus in. And then whizzing around the outside here is what is called a shell or an orbital. And here you've got a particle represented by a little yellow circle with a minus sign in. The first particles we're going to look at are protons. Now, protons begin with a P, and that's how I remember that the protons are positive. And they have a mass, we just say of 1, no unit, and they are found in the nucleus. So I suspect you can probably guess that the red particles down here with the plus sign are the protons. They might also be represented by a circle with a P in. The next subatomic particle we're looking at are electrons. Now they are so tiny that we say they have a mass of 0. They are negatively charged, and they are found in the shells or the orbitals of the atom. And they might be represented by a circle with a minus in, or you might see them represented as crosses and dots. These are particularly important when you're talking about ionic bonding. Now, one way that I remember that electrons are negative is the beginning of the word electrons is a bit like the word electricity, and it would be a negative thing if you were zapped with electricity. The third particle found within the atom is a neutron. The way I remember the charge of neutrons is they are neutral neutrons. The beginning of the word neutron is the same as neutral. They have a mass of 1, the same as protons, so they contribute to the mass of the atom, and they are found in the nucleus. And quite often they're just shown as empty circles, or you might see them shown as a circle with an N in the middle. Now we know the basic structure of atoms, we're going to choose an element in the periodic table and see if we can draw it. And we're going to choose lithium today. Lithium is in group 1 of the periodic table, and it's an alkali metal. The symbol for the element lithium is Li. As with all atomic symbols, they all begin with a capital letter, and if there are further letters in the symbol, they are always lowercase. This periodic table is a little more complicated than the one you would get for your GCSEs. You would see the letter Li with the number 3 by it and the number 7, rather than this slightly more complicated number here. Now the smaller number, in this case 3, is the proton number, and you will generally have a key on the periodic table telling you this. And the larger number, in the case of lithium, 7, is the atomic mass, sometimes called the mass number. This is also on the key. Rather helpfully, the proton number is the number of protons. As you can see over here in this diagram of the lithium atom, we've got 1, 2, 3 protons. Now, because the protons are positive, we also have an equal number of negatively charged electrons. As you can see here, 1, 2, 3 electrons. The proton number, in the case of drawing an atom, is always the same as the electron number. Now the other number we've got here is the atomic mass, and that is the total amount of stuff, or the mass of the atom, the total amount of stuff in the middle, in the nucleus. Because remember, the electrons are so tiny, we say they don't have any mass. To work out the number of neutrons, we do a simple calculation, and we take the proton number away from the mass number. So as you can see down here, we've got 7 minus 3, leaving us 4. So that means we've, out of the total mass of 7, because 3 of them are protons, 4 in the middle of the nucleus, 1, 2, 3, 4, must be neutrons. You may have noticed that the electrons are arranged in a particular way. The first shell or orbital will only contain a maximum of 2 electrons. So here we have 1, 2 of the 3 total electrons, and then the third electron has to go in the second shell or orbital. And that shell can hold a maximum of 8 electrons. So we have 2, 8, and then the subsequent shell also 8. Let's try with another atom, this time boron. Boron has a proton number of 5 and a mass number, atomic mass, of 11. Why don't you have a go now? Find yourself some paper, pause the video and see how you get on drawing a boron atom. Have you done? Let's see how you got on. This is what a boron atom should look like. How did you do? There should be 5 protons. Here, 1, 2, 3, 4, 5. And there should be a total of 11 particles in the nucleus. So 11 minus 5 is 6 neutrons. 1, 2, 3, 4, 5, 6. And because there are 5 positive protons, there must be 5 negative electrons. 1, 2 in the first shell, and then 3, 4, 5. A further 3 in the second shell, making 5. You've been watching Nice Monkey Science. Please like, subscribe, click the bell for notifications. I'd love to get your comments below. Remember earlier we mentioned that the lithium atom was in group 1, the first column of the periodic table. Did you notice that it had 1 electron in its outside shell? Group number tells us how many electrons are in the outside shell. So the fact that lithium was in group 1, we already knew that there would be 1 electron in that outside shell. And boron was in group 1, 2, 3. We ignore this area here. This is an area called transition metals. And the numbering will go 1, 2, 3, 4, 5, 6, 7, 0. So here we have group 3. Boron did indeed have 3 electrons in its outside shell. 2 in the first, 3 in the second, totaling 5. You've been watching Nice Monkey Science. Please like, subscribe, click the bell for notifications. I'd love to get your comments below.